Here's a warm-up. Graph these two equations that are part of this system and then state the solution of the system. Do remember that if you're not actually writing the coordinate pair, I'm not going to assume you know where the solution is, so just make sure you're writing that coordinate pair all the time. Sometimes you graph systems and you'll see that there are no solutions. So let's look at this one. My first equation tells me to plot my y-intercept at 1 and go down 1 and right 1. Now for my other equation, my y-intercept is at -1, and I go down 2 and right 1 again, and graph that line. Something should strike you, and that is that these two lines are parallel. You can also tell they're parallel by looking at the slopes. Remember, same slopes means parallel lines. So if your lines never intersect, then there is no solution. Again, if you were not graphing, you could tell a system had no solution because their slopes would be the same. So equal slopes means no solution because you have a set of parallel lines. Sometimes you'll end up with systems that have infinitely many solutions. Let's rearrange equation 1, or actually let's just graph it in intercept form. So again, if I'm looking for an x-intercept, I set y equal to 0. That would get me 2x equals 8 and x equals 4 for my x-intercept. For my y-intercept, I'm going to set x equal to 0. 4y equals 8, and dividing by 4, I get 2. So they're my two intercepts, at x equals 4 and y equals 2. Grab your ruler and graph that line. The next equation has a y-intercept at 2, and it goes down 1 and over 2. Well, notice what happened. You have two lines that we call concurrent. They lie right over one another, and that's because their equations are truly identical. Never mind my inaccurate graphing there on this iPad. When you have equations that are identical, you will have an infinite number of solutions. And let me show you again in another way that they're identical. If I solved this for y, and divided now by 4, I would get -1/2 x plus 2. So you can see you have the same equations. They're just hidden because they're in different forms. So when that happens and they overlap each other, you need to say that you have infinitely many solutions. There is no coordinate pair that will not work for both of these because they are the same equation. So same equations equal infinite solutions. And you can use the symbol if you wanted to. It's kind of fun to make. Here's a nice little summary page you may want to take a picture of or note somewhere. If you have an equation with different slopes, you're going to get one solution. It'll be the intersection of the two lines. If you have an equation with same slopes but different y-intercepts, your lines are parallel, and so there will be no solutions. No coordinate pairs that will work. And then finally, if you have the same slope and the same y-intercept, you have two lines that are right on top of each other. And so you will have infinite solutions. And it's a good thing to remember because it helps you check if you did your work right. And that's it for this section. Thanks for watching.